Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this session we are going to find out the domain of this function f of x, that is equal to square root of sine inverse, and here we have half times logarithm of 1 minus x to the base 2, right? So let us see how we can find out the domain of this function f of x using the principal value branch of sine inverse function, right? So here we'll use some concept from inverse trigonometric functions. So now let us first consider the function sine inverse theta, and we know that sine inverse theta, it belongs to this interval, that is minus pi by 2 to pi by 2, provided this theta belongs to the interval minus 1 to 1, right? So whenever theta is greater than or equal to minus 1, but less than or equal to 1, then sine inverse theta is greater than or equal to minus pi by 2, but less than or equal to pi by 2. So here we have minus pi by 2, and here we have plus pi by 2, and between minus pi by 2 and plus pi by 2 we have 0, right? So now here we have the square root function, right? So in order to find out the domain of this function, the first condition is that this term, that is sine inverse half of log of 1 minus x to the base 2, this term should be greater than or equal to 0, because this term cannot be negative, because if this term is negative, then we have the square root of a negative number, and square root of a negative number is not defined in the set of real numbers, right? So the first condition is that this term should be positive or equal to 0. So now let us take this term, that is half log 1 minus x to the base 2 as a theta. So now this inequality, it becomes sine inverse theta is greater than or equal to 0, right? And we have just seen that sine inverse theta, it belongs to this closed interval, right? Now here a sine inverse theta is greater than or equal to 0. So this implies that sine inverse theta should be either a 0, that is a 0, or it should be a positive quantity, right? And sine inverse theta belongs to this closed interval. So here from minus pi by 2 to 0, we have all the negative numbers, right? So our sine inverse theta in this case, it cannot take values from minus pi by 2 to 0, right? So we have to discard this interval, right? And from 0 to pi by 2, sine inverse theta has all the values positive, right? So now we can rewrite this inequality as sine inverse theta should be greater than or equal to 0, but it should be less than or equal to pi by 2, because sine inverse theta cannot go beyond plus pi by 2. So here the maximum value of sine inverse theta is pi by 2 when theta belongs to this interval, right? So now we have this inequality, and from this inequality we have to proceed further. So now taking the sign of all these three quantities, so we can now write here sine of 0, then here we have sine of sine inverse theta, and here we have sine of pi by 2. Now sine of 0 is simply a 0, and here a sine of sine inverse theta is equal to a theta due to the property of inverse trigonometric function. So here we have simply theta, and sine pi by 2 is 1. Now let us replace this theta by this term. So we have 0 half log, and here we have 1 minus x, and here we have 1, right? So now let us multiply throughout this inequality by 2, so that we can eliminate this 2. So here 0 times 2 is 0, and here 2 get cancelled. So we have log of 1 minus x to the base 2, and here 1 times 2 is 2, right? So now this inequality, it contains the log function, right? So in order to get rid of this log function, let us raise these three numbers to the power of 2, right? So we have now a 2 raised to 0, then we have 2 raised to log of 1 minus x to the base 2, and here we have 2 raised to 2, right? And here we see that the base 2 is greater than 1, and we know that this function, that is log of x to the base a, when a is greater than 1, and obviously a is not equal to 1, and x is greater than 0. So this function is an increasing function, right? So now here 2 raised to a log of 1 minus x to the base 2 is simply a 1 minus x, because we know that here we have, say, a raised to a log of say p to the base a is equal to p, right? So here the value of a is 2, and the value of p is 1 minus x. So now here we have 2 raised to 0 is 1, and here 2 raised to log of 1 minus x to the base 2 is 1 minus x due to this formula, and 2 square is 4. So now we can easily solve this inequality. So let us multiply this inequality throughout by -1. So the direction of the inequality get reversed. So we have -1, then we have here x minus 1, and here we have minus 4. So now let us add 1, because here we have -1. So let us add 1 throughout. So we have -1 plus 1. Here we have x minus 1 plus 1. And here we have -4 plus 1. So this is 0. This is simply x. And here we have 1 minus 4 is minus 3. Right? So we can also write this inequality as x greater than or equal to -3, and less than or equal to 0. So the domain of this function f of x is given by this interval, that is from -3 to 0. And remember, here -3 and 0 are the endpoints. So these endpoints are also included.